Okay, can you see my screen?
Yes.
Okay. I just wanted to thank everybody for coming to my talk. I'm Douglas Qualiana, KA2 UPW, and this is actually one version of my Introduction to Amateur Radio Satellites talk. So in this talk, we're going to talk a little bit about AMSAT, what you can do on satellites, what you can expect, what do you really need to have, some satellite antennas that you can build. We'll talk about which satellites, when they're up, where, a little bit about tracking basics, and talk a little bit about radios. Well, we don't actually need radios. We'll see. AMSAT is the Radio Amateur Satellite Corporation, and AMSAT is a generic term. Usually we're talking about AMSAT North America, AMSAT NA, but there's also AMSAT groups in the UK, in Germany, India, and they all design, build, and launch their own satellites. There's also other groups that do satellites as well. AMSAT NA is all volunteers. Everybody who's in it is doing something because they either find it fun, or they're doing it to learn something, or they're helping other people to learn. As I said, with the goal is to design, build, launch, and operate amateur radio satellites. AMSAT was founded in 1969 as an AMSAT educational organization, so it's been around for a while. And the first amateur radio satellite, Oscar 1, was actually launched in 1961 by Project Oscar. The convention is that if it reaches orbit and it becomes operational, it gets an Oscar number. I think we're currently up to 109 or so. So there's been quite a lot of satellites. They're not all still up. They're not all still operational though. So what's this all about? What are people doing? Part of it is doing experimenting with new modes of communication using things like forward error correction, slow scan TV. There's APRS work through the satellites. There's advanced digital signal processing. There's analyzing spacecraft telemetry, analyzing the orbits. There's designing and building the actual spacecraft. And there's talking to other amateurs around the world and astronauts on the International Space Station. It's all about having fun. If you're not having fun, you're doing it wrong. And I like to say it's a lot like fishing. If the goal was fish for dinner, then I'd probably go to a restaurant and order fish for dinner. But that's not why people take a day off from work and rent a boat and go out to the middle of the lake and go fishing for a day. It's because they like the process of fishing. And if I wanted to send a message to somebody, I probably wouldn't get on an amateur radio satellite. I'd pick up a cell phone and call them or text them or send them an email. The goal is not to get the message across. The goal is to have fun. And the key is to find the part that's fun for you and do that part. Don't listen so much to what other people are talking about. They're talking about the parts that are fun for them, which may or may not be the parts that are fun for you. So what can you expect? One of the nice things about amateur radio satellites is that the passes are extremely predictable. You can run predictions on your computer for a week or 2 weeks in advance. And unlike HF shortwave propagation, where the band might be dead today, if the prediction program says that the satellite will be above your local QTH, then it will be. So you can plan for the weekend and decide, okay, there's some good passes on Sunday, so I'm going to clean the garage out on Saturday, or the reverse. You'll find that there's some people that are doing grid square chasing, and that's all they want to do is exchange grid squares, or they're trying to get worked all states on satellites, or they're trying to work some DX on a low elevation pass. The satellites, it's important to remember, some of them run in one or more modes, and not everything is necessarily turned on at the same time. As far as the medium, there's voice communications, there's single sideband on what they call the linear transponders. There's also FM only satellites. And there's also satellites that just do data. So in addition to telemetry, there's people sending APRS packets through, say, FalconSat 3, sending little instant message-like communications through the satellite to each other. So what can you expect? Some things are fast, dynamic, and it's different all the time. For example, the guys who are doing grid chasing, you really have to keep up either with the emails or on Twitter with where they are and what grid square they're in if you're trying to get a particular grid square. You can check AMSAT.org for up-to-date information, but there's also the AMSAT News Service Bulletin. There's an AMSAT BB mailing list. There's the Houston AMSAT Net, which you can listen to either on Echolink, or you can get it as a podcast and then listen to it whenever you've got free time. You can check Twitter, especially for the grid square operators, because they'll post where they are, and if the plan changes, they'll put updates on Twitter. And there's also stuff on Facebook. So if you want to find out what's going on right now, there is a web page on the AMSAT.org website, just status. And if you go there, it will list all of the current reports from other amateurs as to what they heard and what they didn't hear. And there's a lot of information actually kind of encoded in this, if you look at it carefully. So the AO7, I'm just going to pick out AO7 and the ISS as an example. When AO7 is fully illuminated in sunlight, it switches back and forth between what they call mode A and mode B on about a 24-hour cycle. So if you're just interested in one of those, you can come to the status page and look and see which one it's in right now. Similarly for ISS, if you're trying to talk to the astronauts, you can look at the ISS FM page, and if you see the yellow, that's not what you're looking for. You're looking for the purple lines. And the key to this is to mouse hover over the number, and that will tell you the time of the report and also the call sign of the station that put in the report. You can then go look up where that station is, or you can do the predictions for the ISS with the time, and you can find out what part of the world the ISS was over when the crew was active. And there's a good chance that if they were on today at a certain time, they'll be on tomorrow at that same time. However, that might be when the ISS is not over the US, but this will tell you. And then there's some things that don't change much. Orbital mechanics, a lot like Ohm's law, hasn't changed much recently. There's a couple of good books. Escobar has one called Methods of Orbit Determination, and there's another one called Fundamental of Astrodynamics. Both of these get into some sometimes heavy mathematics for doing the calculations. And some of Newton's colleagues even said that when he was trying to figure out the orbit of the moon, it used to give him headaches. So it's just a warning. Now, what kind of equipment do you need to get on the satellites? There's this myth that you need multiple large antennas, great big huge satellite dishes, hundreds of watts of RF power. You got to invest thousands of dollars of your money in the radios and years of time just to learn the basics before you can talk to anyone. So the myth is that you're going to need some great big huge dish or something, and that's not the case at all. The reality is you can get started. You can start making QSOs and getting QSL cards and working towards worked all states or whatever you're trying to get with something as simple as a 2-meter FM HT and either a 70-centimeter HT or a handheld scanner, depending on which satellite you want to listen to and what bands it's on, and a couple of homemade antennas. If you have an all-band, all-mode radio like an FT817, that could be your complete radio station, at least for getting started, just to dip your foot in the water and see if this is what you like or not. The question is, which satellites do you want to use, and what do you actually want to do? Do you want to talk to people? Do you want to collect telemetry? Some satellites use just FM, others use linear transponders that have single sideband and CW. So take a look at what equipment you have and see if that matches up with any of the modes that a particular satellite is in, and then you might be able to make QSOs on that satellite. If you're just interested in collecting telemetry, you can get started with your computer and a $15 RTL SDR USB dongle. The dongles receive from about 50 megahertz to 1.7 gigahertz. They're receive only, so you won't make any QSOs, but if you just want to collect telemetry, you can get started for about 15 bucks. Or you can download some audio recordings of past satellite passes from the SatNog's website. There are a couple of hundred ground stations. You can go there and say, I'm interested in a particular satellite. You pick it from a drop-down box, and it will give you a list of all the observations and all the recordings. And then you can just go download the recordings. You can also listen live, at least on 2 meters and 70 centimeters and some other bands. If you go to websdr.org and just pick the part of the world and pick the band that you want to listen to, and it'll give you a list of stations that have receivers that you can connect up to and listen to the audio. As a tip, each of the stations has their 6-character grid square where they're located. So you know where they are. You can use that location information, plug it into a tracking program, and find out when a particular satellite will be over that station. So you can listen to the satellite while it's over Europe or over Australia or something. So just as an example of a portable QRP satellite station, this is Keith Pugh. He used to do the demos at Dayton. He has an FT817 around his neck, and he's got an Aero antenna, which is 3 elements on 2 meters and 7 elements on 70 centimeters. There's a battery on the table. And if you just want to get started, this is about all you need. You point the antenna at the satellite, and whatever the satellite hears, it's like a repeater, it'll just retransmit it. The disadvantage to this is that you can't hear your own signal coming back down. So if you want to get serious about this, you'll want to get a second radio to do the reception. What Keith used to do sometimes is he would get 2 FT817s, what he used to call a FT1634, and use one for transmit and one for receive. So when I got started, this is actually my second station, and I would set it up on the back of the car and work satellites from wherever I was. The key here, part of the key, is to figure out what you've got and what it can do to help you get on satellites. So I had a 5/8 2-meter mag mount, and the mag mount's just made out of some magnets and some parts from the decking supplies at Home Depot. The antenna here is actually a Quaggy antenna. If I was doing this again today, I'd probably use one of Kent Britton's cheap Yaggies. For the uplink, I had a 1980s vintage 2-meter HT that on a good day, it would put out 1.5 watts. I got a 435 megahertz preamp from Downey Smartwave, an old Hamtronics down converter, and I had a 10-meter only HR2600 that I used, connected up to the down converter, so the signal would come down the antenna, get amplified by the preamp, go to the down converter, and get converted from 435 down to 28, and then you could listen to it on the HR2600. As a tip, if you want to build something for mobile operations, it's very handy if everything either folds up or comes apart. And I found that if you want the Yagi to come apart, you can use camping cord locks. And these are usually used for holding ropes. You can find them in the camping section at various stores. But you put one on each side, and you can quickly press this and slide it off the element, or slide it on and slide the element through the boom and hook it all up. And it only takes a couple of seconds. This is a close-up of the antenna that I built. I had some challenges getting the spreaders through the boom, so I got some wooden spools and glued them in. You'll note that the preamp is just tied to the boom with a strap. I like to point out that there's no cable loss here because there's no cable, just a couple of connectors. The whole thing's powered by a 9-volt battery that is attached just with some alligator clips, and the battery's held on with some duct tape. So it's very complicated, very sophisticated. If you don't want to build your own antenna, you can spend some money, you can buy an antenna. There's a lot of people using the Arrow antenna on 2 meters and 70 centimeters. If you're interested in 2.4 gig, you can get a down converter. And what you see him holding up, the little V-shaped corner reflector and the dipole, that's the whole 2.4 gig receive system. And what comes out of that box comes down the cable on 2 meters. So just to stop and think about this for a minute, why does an antenna work well? Does it work well because you paid a lot of money for it? No. It works well because it has metal pieces that are the right size, the correct shape, and the proper distance from other pieces of metal. By analogy, just to point this out, if you're a municipality and you need a bridge, you can't just go buy a bridge out of this month's edition of Bridges and Tunnels. You have to engineer it, or somebody has to engineer it. You don't have to be the one that actually engineers it. You can take someone else's engineering and modify it to meet your needs based on what you actually have. I like this quote from Jerry Evans: engineering is the art of making what you want from things that you can get. So some satellite antennas, you can use a regular mag mount for 2 meters. Kent Britton has a collection of cheap Yagis for lots of bands on his website, or just Google cheap Yagi and you can find one of his papers. There's also a cheap Leo that's a combination 2 meter, 70 centimeter antenna with a splitter that you can make out of a couple capacitors and some wires that you wind around the pencil. It's very simple. You can use an arrow, or you can make a homebrew arrow yourself. There's some cardboard corner reflectors I'll talk about in just a minute, and some simple 2.4 gig antennas, an umbrella dish, homebrew helix, patch from mint tin, and some really complicated ones made out of cardboard and aluminum foil. So on the left, we have a 2.4 gig horn antenna designed for receive. It's made out of some cardboard. You can probably get the cardboard for free if you're really cheap. And if you go to the dollar store, you can get a roll of aluminum foil for $1. Get 2 rolls, should be enough. I made mine, and as you can see, it's held together with duct tape. It works really well. It's got about the same gain as a 2-foot satellite dish. On the right is a 70 centimeter corner reflector. Both of these are designed by Tony, AA2TX, now Silent Key. But the documents and the specs for how to do it are both on the web and in some previous AMSAT symposium journals. The corner reflector is basically just a dipole, and it's held in place by a small cardboard box. And then there's a large corner reflector just made out of aluminum foil. You hold it up with some more cardboard to point it in the direction that you want to go. I also made a satellite antenna. It's actually a dish made out of an old umbrella. I stitched some metallic thread into the material. If you want to do this, it takes a little bit of time to do all the stitching, but it's actually pretty easy. The threads don't need to touch each other. The only thing that's really important is the spacing, and you want it about 1/10 of a wavelength of whatever you want it to reflect. We measured this. It had about 15.5 dB gain on 1.2 gig and about the same on 2.4 gig. I also built a 2.4 gig helix, and this was made out of a towel rod and a ventilation pipe end cap, both of which I got from Home Depot using a technique that's called design by browsing, where you kind of start with what you need and you walk up and down the aisles until you see something that's close to what you want. So I needed a square piece of metal that was not made out of iron or steel to serve as the boom. And walking around, I found an aluminum towel rod, and it cost about $3. So this is the finished 2.4 gig helix. It's about 20 turns. And the way you make it is to find a wooden dowel that's about the same diameter as your helix and make a template. So the way to do this is get in your favorite computer program and draw a box where the length of the box is the helix circumference, and the height of the box is the space in between the turns on the helix, and draw a diagonal line. And if you need more than one turn, which you probably will, you edit, copy, edit, paste, make more boxes. And then cut this out, glue it to the wooden dowel, and get a piece of wire and wrap it around until the wire covers the red line all the way going around. Now, whether you need right hand or left hand circular polarization, you draw the red line the other way. You can also get a parabolic dish out of a snow sled or snow saucer. It's not quite parabolic, but it's close enough. So we're down a couple of dB because we're not perfectly parabolic, but we're still up about 10 dB for the gain. And people ask, well, where I live, they don't sell snow sled saucers. eBay. Another really simple antenna for 2.4 gig is made out of the top of an Altoids tin with the corners cut off. There's one solder joint that you need to make on this, and if you're a QRPer or a builder, you probably already have a bunch of these Altoids tins just sitting around. This is a simple measure, cut, solder, drill a couple holes to connect the connector, and it just works. It's not perfectly circular. It was down about 6 dB from circular, but it's 7.5 dB gain in the other direction. You're probably going to want a preamp if you're doing work on satellites. There's a bunch of places that you can get preamp either as finished products, or you can build your own from a bag of parts. I built this one. It's all surface mount, but the key is to use the right tools. If you have the right tools, surface mount is really easy. If you don't have the right tools, surface mount is going to be hard. This one worked out nicely. It's got about a 1 dB noise figure. And it's actually pretty small. It fits in a different Altoids tin. There's a quarter for the size. So it's small, but there's only a couple of parts to solder on. So the question is, which satellites are active now? Not all of them are active at the same time. Different satellites have different modes, but there's usually a schedule published. You can see the status page, again, on the AMSAT news service bulletins, the mailing list, the AMSAT website. Look on Twitter for the grid squares. And some of them have what I call enforced schedules. So AO7, because the batteries have failed, it only works when the solar panels are illuminated by sunlight. So if you look at where the satellite is, you can determine whether or not it's in sunlight. And if it's in sunlight, even if you're not in sunlight, then the satellite should be on. The next question is, when is the satellite available for you at your location? So far, there's only one amateur radio satellite that's geostationary. So the rest of them, being in low Earth orbit, will appear to move. They'll rise up above your local horizon and set from anywhere from a few minutes to maybe 10, 15 minutes. But the times that they do this are different every day. So you'll need a tracking program to figure out the exact date, the exact time, as well as what direction in azimuth, which is your normal compass heading, north, south, east, west, as well as the elevation, which is the angle above the horizon that the satellite is at. Now, the satellite can only see a portion of the Earth, which they call the satellite's footprint. And if you're in the footprint, then you can get a signal up to the satellite, and you can listen to the signal coming down from the satellite. But you have to be in the footprint. If you're not in the footprint, then it's below your local horizon and you can't get a signal in and you can't hear it. So how do you do this tracking to figure out where and when it is? Originally, it was done using simple rotating paper computers, where you'd line up the paper and it would tell you. But now, pretty much any computer you can get, no matter what it's running, Windows, Linux, even your iPhone or your Android phone, anything will do the calculations for you. What you do need to do is you need to get your latitude and longitude, and you need this pretty accurately, but not to 16 decimal places. You need a current set of orbital elements called the Keplerian elements, or the two-line elements. You can decide whether you want a graphical display or just some text output. The orbital elements, I should note, need to be current. You really want ones that are less than 2 weeks old, and you'll want your computer's clock to be accurate. Now, if you don't want to go through all that and install the software, you can go to a website like Heavens Above, click on radio amateur satellites, or you can go to the AMSAT website at amsat.org/track. In both cases, you need to know your current location so you can put that in so that it can give you accurate results. There's also other software in the archives if you're running older computers or you just want to see what the older stuff looks like. So the current stuff, if you run a program like NOVA, it'll give you a world map. It'll show where you are, and it'll show you where the satellites are. So the circles around the satellites are the footprints, and those show you the part of the Earth that the satellite can currently see. If you're in the satellite's footprint and somebody else is in the footprint, then potentially you can have a QSO. Right now, neither one of these would be overhead in Dallas, so I would not be able to use either one of them until they get over my local horizon. This is a slightly different depiction of pretty much the same information. You can see that the footprints actually are circular if you look at them on a globe. If you want to run Linux, DOS, Windows, and even on your Android phone, you can run a prediction program that's just called Predict. As I was saying before, you can go to the AMSAT website, pick the satellite that you want, how many passes you want, and put in your grid square or your latitude and longitude, click the button, and it'll give you a bunch of predictions. Same thing for Heavens Above, but again, remember, you need to put in your current location. The default is 0 degrees lat, 0 degrees longitude, and then if you don't change it, you'll get the wrong answers. If you put in the right location information, you should get the right answers. Heavens Above sometimes will not list the very low elevation passes that you might be interested in if you're interested in working DX. And sometimes the names that they have are not exactly the same names as listed in some of the other programs. So going back, the key to this is, what do you want to do? Do you just want to make a single satellite contact just for the fun of it, to say you did it? Or do you want to make a lot of contacts? You want to try and go for DXCC or VUCC or grid square chasing? Or maybe you're not interested in talking to people at all. You just want to send and receive data like APRS, or you want to just get recordings and you can do digital signal processing to try and extract the data from the recordings, or get the telemetry. The AMSAT website has archives of all the satellite telemetry going back quite a bit. And it's still there, so you can go back and analyze it. Or maybe you're a builder and you want to help build a satellite, or you want to perform ranging and work out satellite orbits, do the mechanics for the mathematics. What part is fun for you? I'll talk for a minute about digital signal processing. A lot of the satellites, for example, AO40, ARISAT-1, FOX-1, and some others, use a Reed-Solomon or a Viterbi decoder to do error detection and correction. So if you receive the signal, but you receive it with some errors, the software will be able to find which bits are wrong and correct them so that you get the correct data that was actually transmitted. The AO40 scheme is actually the same technology that NASA and JPL used on the Voyager missions to the outer planets. And you don't need to know the details of Reed-Solomon or Viterbi decoders. You just need a computer, get a sound card or a dongle receiver connected up to your computer, and you've got data. And I used to say, radios, you need radios, or your friends need radios. Because when I was interested in doing some digital signal processing on a particular high-speed recording, I had to get some friends to make the recordings for me because I didn't have the special radio to get the data. But now you can do it with just an internet connection on WebSDR or on the SatNods. You can download free telemetry software either from the AMSAT site or a DK3WN or WM, and then you can collect and analyze the telemetry on your own. What I did was a 9600 baud, 38.4 baud sound card modem. So there's no TNC, there's no hardware modem, it's all software. Audio comes in from the radio or from a recording, and the DSP software runs and takes the audio and determines what the bits are from the data that was sent. It demodulates the data for you, and then you get telemetry. You decide what to do with the bits. I decided to decode the satellite telemetry. So you can either, let me back up. Different project was the brute force demodulator, to use the computer to try every possible combination of baud rate, frequency, and phase on a recorded signal to get any of the bits that were in there and get them out. This doesn't have a fancy GUI, but this is from FalconSat 3. And if you go through this, these are all AX25 packets that were demodulated out of the recording. There's APRS packets from N7 NEV, and there's telemetry from the regular telemetry, as well as some from the battery recorder. I'm sorry, battery control regulator. I did a separate satellite telemetry program just for AO51 and tried to make this a little bit visual. So if you're showing the telemetry from the solar panels, you should have a picture of the satellite and the solar panels and what the solar panels look like so that you can see what it is that you're actually getting measurements on. Same thing for the batteries and the battery control regulator. These are what the actual trays on the satellite look like. And then if you want to look at all of the telemetry, there's a separate screen for the telemetry as text. Currently, the Fox satellites, as well as the FunCube satellites and a couple others, send live telemetry, and they each have their own internet web page. It says Fox only, but FunCube also has an internet web page where you can see the current telemetry as received from whoever's listening anywhere on the planet. So their software will demodulate the telemetry and send it to an internet server and display it for everybody to see in real time. If you don't want to do real time, or you're interested in some of the older satellites, there are FTP archives on the AMSAT site for all the old telemetry. Your question is, are you interested in telemetry? What is it that you want to analyze? You want to look at the orbit, the orbital decay, if we know that it already decayed, or try to predict when it is going to decay. You can look at the solar panels and figure out what the spin rate of the satellite is, look at the temperatures as it goes into and out of eclipse, or whatever it is that you're interested in going after. When ARISAT 1 was in orbit, we had a live telemetry page, so that anybody, anywhere on the planet who got a telemetry packet would send it into the server, and it would come up on this page, get updated, and everybody could see it. I like to say, if you don't have no radios, no problem. It's on the web. You can see the telemetry. DK3WN also has an extensive collection of satellite telemetry programs and listings for just about every single satellite and the telemetry that people have sent in to him. So going back to just a simple voice, if you want to make a QSO, the most important tip I can give you is listen. The satellite will hear you. Don't transmit if you can't hear the satellite, because you'll just be interfering with people who can hear the satellite and who are trying to make QSOs. If you can't hear it that well, or you can't hear it at low elevations, get a preamp. Preamp makes a huge difference, particularly for older receivers or receivers with high noise figures. Practice a couple of passes just listening, tuning the receiver, because there's Doppler shift. And so the signal from the satellite will appear to shift lower in frequency during the whole pass. And of course, there's a key part of this is dropping your call sign in at just the right moment so that it gets through the transponder and everybody hears you. It takes a little bit of practice, but it's not hard. My recommendation is start with a simple station that will let you make contacts. And once you get it working, then make the station better and fancier. As a tip, if you want to avoid a particular big gun station, or if you're trying to work a particular DX station, then you can look at the passes, look at the footprints, and figure out when that other station is or isn't in the footprint, but you are. I like to say satellite predictions work both ways. You can find when people are and when they aren't available on the satellite. If you want to go mobile, first set up the station at home, make a couple of QSOs in the driveway, verify you have it all working together, and then take it on the road. If you want to work satellites mobile from the back of your car, always carry an extra set of car keys so you don't get locked out. As far as using the telemetry, perhaps in an educational setting, I had a couple of ideas that people asked me to put in here. You could have the students do calculations, for example, convert the latitude and longitude from decimal numbers to degrees, minutes, and seconds. You can have a look at the telemetry, look at the raw reading, which might be, for example, a 27, and run it through the telemetry equation to get the actual value, which might be 45 degrees Celsius. You can look at the solar panel voltages and use that to calculate the spin rate of the satellite. And you can look at what happens when it comes into and out of eclipse at the temperatures. Might not be what you think. You can look, it's possible for the satellite to be in sunlight, but you're in darkness. You can look at the footprint and see where this is or when it is. Do other calculations like convert mission elapsed time to the current date and time, either in local time or UTC. And then there's some more advanced suggestions. For example, figuring out how much power actually hits the antenna if the satellite's transmitting a certain power on a certain frequency and it's a certain distance away. If you know how big your dish is, you can run it through a formula and figure out how much energy actually hits your dish. So as an example, one of the telemetry collections I was looking at, this was the current from the solar arrays. The satellite's in sunlight starting about 106. But something interesting happens about 226, where we're in sunlight, but the total voltage from all of the solar panels suddenly drops way down. If you look at this closely, well, if you look at it at first, it doesn't seem to make any sense. If you look at it closely, you'll see that the Z plus side, which is the top of the satellite, is at a high point, while the total current is at a low. And what's happening is that the top of the satellite is the only side that's getting sunlight. The other sides aren't getting any sunlight, so they're in darkness. They're not producing any current. So questions, what questions do you have?
Okay, we got quite a few in the chat thing. let's start. We haven't got their hands up yet. So let's start with the chat. Barry, you want to pick that up? Hello, Barry. You're muted. You're muted, Barry.
Okay, got it. Okay, someone is interested in more detail about the data and telemetry use. How do you find out more?
It depends on which satellite. If the satellite is one of the AMSAT satellites, there's probably a telemetry program that somebody has already written that will let you see what the current telemetry is. Depending on what you're interested in, there's probably an article in an old AMSAT symposium proceedings or in an old issue of the AMSAT journal that talks about the different types of telemetry and the values and the conversion equations that you can use to go from what the numbers are that are actually transmitted to what they actually mean.
How do you find out about which satellites permit the transmission of telemetry and which don't?
Just about all of them transmit telemetry at some point in time or other. Some of them are continuous, but some of them are on a schedule.
Okay, so you'd have to go to the different programs to talk about the satellites.
There's probably a different satellite telemetry program for each satellite. Either the AMSAT site or DK3WN site probably has a telemetry program that you can use to get data from either out of the recordings or from a live pass.
Okay. The homebrew antenna, like you showed, such as the umbrella, can they also be used for uplinking or just receiving?
I haven't tried it at high power, but you should be able to use it for transmitting as well as receive.
Okay. Can you speak more in detail about transmitting data and telemetry?
That's a little bit vague, but if you wanted to do, say, just APRS digipeating through, say, FalconSat 3, if you've got an HT that does APRS, you can set the transmit and the receive bands and transmit when the satellite's overhead. You might need an antenna with a little bit of gain, depending on how much power you're running. But it'll digipede through FalconSat 3 and come back down. Sometimes ISS is also in a mode where it's digipeating, and you can send packets through the ISS.
Do the satellites conform to the same downlink telemetry standard?
Pretty much, with the exception of the Fox series, they all have their own formats.
Okay.
So that's why you probably need a separate telemetry program for each one. The Fox satellites and the RadFX satellites, there's one telemetry program called Fox Telem that will do all of those. Otherwise, DK3WN or something from the AMSAT site for the particular satellite that you're interested in.
Okay. Can you go into some detail about AX25 over satellite?
Yeah, what exactly is the question?
That's such a huge topic. I imagine you could spend hours doing that. So, where can you find out more information?
For some of the satellites, they transmit AX25. For example, FalconSat 3 sends 9600 baud packets as AX25. But the other satellites, for example, the Fox series doesn't use AX25. It depends on the particular satellite.
Okay. Okay. There's a junior high school in Australia where the teachers have documented ham DIY projects for the students, including DIY antenna rotators, etc., specifically transmitting telemetry. Okay, that was just a comment. Okay. There's one person that's interested in helping out AMSAT. How does he's contacted AMSAT North America several times, but never heard back about how he can help out. Who should he call?
If you want, I can make some inquiries. It depends on what you're interested in doing, but I can probably find out the person to contact. Or if you call the main AMSAT number, you should be able to leave a message. Somebody should get back to you.
Okay.
Is that Scott?
Yes,
Yeah,
it's
yeah.
Hi, Scott. That's Scott McGilvery.
Okay. What is a good FM satellite for a beginner to start out with?
You could start out with one of the Fox satellites. Sometimes AO27 is active. You have to check the schedule. Sometimes the ISS is configured as a FM digipeater, but you have to check the schedule. If you just want to receive, sometimes UO11 is still transmitting on 2 meters, and it has a simple FSK signal. There's not much telemetry left, but it's still a signal you can receive.
I have a question.
Okay, we'll get to those in a sec. We're almost done with that. Can you
Yes.
recommend a good preamp, 2 meters or 440?
A good preamp is one that's going to have a low noise figure and at least a moderate gain. I don't have any specific recommendations from particular companies. There's a bunch that sell preamps, and there's a bunch of places that sell them in a kit if you want to build them. Whether you build or buy is your choice, but you want to get the lowest noise figure with at least some moderate gain.
Okay. Can you uplink using AX25?
For example, for FalconSat 3, you can. Not for every satellite, but
So obviously, they're going to have to check online to check, because it's so big a country. You have to look online to see when the satellite's going to be in the footprint. So that's the most important thing you can do. Okay, Dan, we've gotten just about every question, but they want to know if you are open to follow-on questions directly by email and stuff.
yeah, if you send an email, share this back up. Send me an email to my Gmail address and I'll take questions.
Okay, we're done with the chat, Dan. You want to go ahead and take the hands?
Yeah, I will. Before I go any farther, Doug, would you email the presentation to me so I can get that out there by the
Sure.
afterwards?
I'll send you the presentation, and I also have a PDF that has all the links that I talk
Super.
about in the presentation.
Love it, love it, love it, love it. Okay, William, I'm sorry. Go ahead, and I got you. You're gonna have to unmute, and then you can take your. Go ahead and talk. William, you're muted. William. William Monday, I think it is.
Here we go.
Okay.
There you
All
go.
I came in late and I see that this is recorded. How do I find the recording to play back the half I missed?
Oh, that's the easy one. I'll send it out. It'll probably be tomorrow sometime, but I'll send it out to everybody. If you got the invite, you'll get the link that shows where all the recording documents are on the same source.
Okay. Thank you.
No problem. Is there anybody else? This has been a very good presentation. I'm surprised we don't have a slug more questions, but we got people who want to take you offline, it looks like. So
I have plenty of questions. I'm afraid I'll just bogart the entire environment though. I was the one asking about the telemetry uplinks. My name is Michael, KI6HEF. I have a background in emergency management and looking to, utilize my command and control background in the DoD to push, very terse emergency management traffic over the data uplinks, and just trying to look for and understand what the art of the possible is in terms of which birds permit this. And where can I can find more information and maybe some how-tos, that kind of thing.
Depending on how much data you're looking to push, you have to remember that you're competing with all the other amateurs who are trying to have fun, and you only get on the LEOs maybe 10-15 minutes maybe 5-6 times a day.
Yeah, it'd be a quick burst of a small packet. So so do you have to, do you stay in queue? Do you have to basically, a data transmission competes with a voice transmission, whoever gets there first wins?
No, it's usually if the satellite's doing AX25 like FalconSat 3, then that's all it does.
Okay.
So you could upload a message to the bulletin board system for someone else to download. It would be at 9600 baud, and you would be competing on the uplink against other stations that are trying to uplink. But there's software that will take care of breaking up your message and uploading it to the bulletin board.
Okay, I'll be one of the ones that will start bugging you an email. So I look forward to digging in a little
Send
deeper.
it over.
I was also the one that mentioned the school in Australia. It's pretty remarkable what they've done. I think I forgot to put the link in. It's called SARCnet, SARC.net or SRC.net, and it's a school. You know, the teachers. I'll put it in the chat. The teachers created these DIY projects that they've published, and they've created Arduino and Raspberry Pi loadable modules you can build your own, you know, rotator, very similar to SatNOGs, but it looks like it's easier to build than the SatNOGs components, and very remarkable in what they were able to accomplish with kids.
There's a number of projects that incorporate Raspberry Pis. For example, there's one called Fox in a Box, which is a Raspberry Pi and a USB dongle for receiving telemetry from the Fox and RadFX satellites. And it's basically you download an image, put it on an SD card, connect up the RTL SDR dongle to the Raspberry Pi, and put out a simple antenna somewhere where it can see the sky, and just let it go, and it'll collect a couple of telemetry packets every pass.
I'm very much looking forward to speaking with you further. Thank you.
Okay, Michael,
Fox in a box.
be sure to put your information there in chat for everybody. Ria, you got your hand up. Go ahead and take it.
Hi. So I heard the magic words, Raspberry Pi. Have you ever encountered one of, where's my, anyway, Raspberry Pi Pico? Is there any plans to do anything with Raspberry Pi Pico?
Pico. I'm not familiar with the Pico.
Well, Pico is essentially the it's sort of like their answer to Arduino, although they're really not competing. They're more of it's a microcontroller kind of thing, and it's $2, and it's right here. I'll show you one. So Raspberry Pi made their own silicon, right? And it's you could program it with C or MicroPython. And I was wondering if there's anything, you know, that could be something to deal with satellites with those. Has anybody been looking at developing stuff with those, maybe fun projects? Because I see it could be very cheap. It could have a very enormous potential, particularly for, I say, educational endeavors.
I don't know of any projects specifically with the Pico. That would probably be a question to ask on AMSAT BB or somewhere if anybody's working on that.
All right, just thought I'd mention it. Thank you.
Thank you, Ria. Anybody else?
I'll ask another one. Doug, you mentioned that there was a repurposing of the interplanetary satellite communication protocol. I actually worked on the Galileo mission, and they had, you know, some uh-ohs related to high band communication. But I was wondering, you know, what other repurposing activities there are. You know, it's one of the things I tried to dig into was to search what NASA had put out in the open that could be repurposed for, you know, ham use.
You can look at some of the papers that have been written both for AO40, for AeroSat 1, and for the Fox satellites. in particular. All of those use some combination of Reed-Solomon codes as well as Viterbi decoders. The FunCube satellite also has a similar Reed-Solomon Viterbi decoder.
Okay, yeah, I'll be happy. I'm chomping at the bit to have communication with you over email, so I'll be bugging you. Thank you.
Okay.
Sounds like it. Okay. This has been a good presentation. I really appreciate you doing this, Douglas.
You're welcome.
When I talked to him earlier, we had a one-to-one eyeball on Zoom, and he didn't have the hat. He didn't have the background. He spruced this up a little bit. Okay, one more time. Be sure to get your questions in the chat. Everybody will get a copy of chat afterwards. So if you got links to share, stick it in there. And as soon as I get Douglas's presentation, I will include that so everybody gets a copy of everything we're doing tonight and everything's been said.
Do we need to register with you to make sure we're on that email list, or the fact that we got this link, it guarantees that?
Well, I send it out to the same source all the time. So if you got it, then if you don't have it by tomorrow afternoon sometime, send me an email, k7rex@arl.net, and we'll be sure to get it to you. But I'm sure that you'll get it.
All right, thank you.
And next week we have another one on satellite, right, Dan?
I believe so. I believe so. Yes, I have to look at my list. We're going to try to do this this kind of stuff more often. There's people like Doug and Michelle and a whole lot of people very knowledgeable out there. We like to pick their knowledge and see how we can interface it to the fun of this hobby. Okay, anybody else out there?
Do you want to talk about the Ham Expo satellite track, Michelle?
Sure. Douglas is headlining. He is leading off the space and satellite track all day Saturday at Ham Expo in mid-March. It's coming up. I'm sure a lot of you will be there. Ria is also speaking, I believe, in the expert track on SDRs, and it's going to be wonderful. There is also a booth with a booth has a video set of video presentations about amateur space radio, so amateur satellite, video track there, and lots of handouts, fun. We have 2 social events that we are doing, so please check out Ham Expo. There will be a lot of content of all types, but a special exhibit and all-day track, speaking track, just for amateur satellite.
Can you put the link to the expo in the chat?
Yes, I will do that right now.
Thank you, Michelle. Rhea, you got your hand back up.
Yeah, that's the point of correction. I am not doing a presentation on SDRs. Actually, I try to keep it a little different this time.
Oops, sorry about that. I
No worries.
misspoke.
Yeah, no worries. I'm doing one on systems integration, including connecting all your equipment and a special breakout on Node-RED. So, what hams are doing with Node-RED, and that's what I'm doing this time.
Okay.
Yeah, Ria, do you want to add anything about anything else about Ham Expo that you know about?
Well, Ham Expo, so generally, like my presentation is not the same as last time. Other people I've talked to who presented, they're going to be presenting different topics and a number of different things. I think Eric tries to keep it a little different. David Minster, the ARRL CEO, is going to be the keynote speaker, and there is going to be a special presentation on the ARRL lab, I believe, as well. And the lab is a benefit that I've been trying to tell members about. I'm sure the section managers, especially if you're not talking about the lab, then you should be talking about the lab. The Technical Information Service is, I think, a fantastic ARRL member benefit, and members should be knowing about it. And you know, when I tell people about the TIS, they didn't even know that we had that. You know, they give you well-researched, authoritative answers from the ARRL lab. So you know, people ask all sorts of stuff, and I get copied on all of the responses in Hudson, and it's really nice, you know, that this is available for members. So I encourage people to take advantage of it. Back to Ned.
Okay, Michelle.
I'm good. Back to you.
Okay, thank you. Are there any more questions out there? Real good some questions here, and I think we need to follow up on some of the stuff they're suggesting.
If anyone is looking for Doug's background, he put the link to it in the chat.
Everybody will get a copy of our
Right.
chat tonight, so you'll see that. Make sure all your links and helpful information is in there. Okay, every time I ask this, I get one. So any more questions? Any more answers? I really appreciate this. Douglas, thank you for coming on and doing this. Yes, appreciate it a lot. We'll have another presentation focused on Aries tomorrow. So those who's interested in Aries, come on back. And if not, we'll see you next Wednesday. With that,
Thanks for having me.
Thank you all for coming. Thank you, Douglas.
thank you,
Thank
Douglas.
you for your help, Michelle.
Keep in touch.
For you all.
Keep in touch, Douglas. We'll
Thank
like
you.
so we could interface against more in the future. Okay, 73s, everybody, and I'll keep this open afterwards. So after we close the presentation, you can log back in. Oh, wait a minute, Jim's got his hand up. Jim, go ahead. Oh, he's
No, that wasn't it. That wasn't that was just waving goodbye. That was
yeah,
a wave.
they're using this. They got I know. I don't.
That trick you. That was a trick.
Yeah, they used to have a blue hand, and it was different from anything else. And this yellow thing kind of, especially whatever kind of screen you got. Okay,
Dan, take a look at your chat. The chat. I sent you a private message about what I was talking to you about before.
Okay, sounds good. Okay, everybody, I'm going to say 73s. If you want to chat afterwards, log back in and just have a good old after meeting chat like you would at a club meeting. 73s, and see you all, some of you tomorrow. Hopefully I'll be here Wednesday night, next Wednesday. 73s.
730.